So, LeetCode problem 2591. Distribute money to maximum children. You are given an integer money, denoting the amount of money in dollars that you have, and another integer children, denoting the number of children that you must distribute the money to. You have to distribute the money according to the following rules. All money must be distributed. Everyone must receive at least $1. Nobody receives $4. Return the maximum number of children who may receive exactly $8 if you distribute the money according to the aforementioned rules. If there is no way to distribute the money, return -1. Okay, that was a lot of words. So we must distribute all the money. Everyone has to get at least $1. Nobody gets exactly $4, and then we need to return the maximum number. We need to return the children that received a maximum $8. Return the maximum number of children who may receive exactly $8. So we need to give the money to the children. Okay. We need all the money must be distributed. Okay. Okay. Okay, this is a lot of math that we need to do. Okay, so everyone must receive $1. Okay, everyone must receive $1. Let's look at some discussion questions. Yes. That's not a good sign. This question is so easy. Why does it only have a 19% acceptance rate? So I'm gonna say mathematician doing charity. Try to give each child $1. If you can't, there's no valid distribution. Once every child has $1, each child is given an additional $7 until either 1, we run out of children to give money to, or 2, don't have $7. And there's no money left. There's one child left remaining. We'll give them $4, give them that money. Okay. And that's very helpful. Everyone must receive $1. So that means the money has to be greater than the children. So, that's our first thing we can do. If money is less than children, then we return -1 already. Okay. Progress. We're making progress. So that's if our money, so we need to check if we have one child. If we have one child, the money has to be the money cannot equal 4. Does it say it has to be what am I thinking? If the money is more than 8, because we have to distribute the money. We have to distribute all the money. So if we only have one child, if children is equal to 1, right? If children equals to 1. So we also need to check here. The money has to be more than $1 and it can't be 4. So if money is equal to 4 or money is equal to if money is equal to 0, we'll return -1. Okay, no, we should make it less than, if it's less than 1. And then if money is equal to 8, return 1, else we return 0. Right? So if we only have one child, so we need to distribute all the money. So if it's more than $8, we can't, because we only have one child and they can at most get 8. Right? Okay. So we're just trying to figure out all the edge cases. Okay. This one was very helpful. We do need a variable. So the variable will be, we need to keep track of like how many kids we can give 8 to. So var children 8, children with 8, and we can just use the min right now. We'll just pass in the money divided by 8, and then we can also, this would also be the children. So that's the maximum number of children that can get 8. So we have our, okay. So we have this. We need to keep track of how much money we have left and how many children we have left. Children left. Okay, so we can do for children left. So that would just be children minus children of 8, and then money left will be money minus our children left. So we're dividing, so we need to multiply, so we can do children times 8 here. Okay. Let me check Twitch. Okay. So we want to check. Wow. Okay, so we need to loop through our children of 8 while that is greater than or equal to 0. It's greater than or equal to 0. We also need to do this check. So we need to check if the remaining money is enough for so we need to check if the amount of money we have left will be enough for everyone to get $1. That's what we need to check. So if money left is less than children left, then we need to do some math. Since we're looping, our children were 8. We have to reduce that because, I mean, they can't have 8 anymore because it won't work. So we can do minus equal 1. Then we add some money back to our pool. And then we add some children back to our okay, so we don't have enough money for the remaining children, so we need to reduce. Okay, so this will be we need to check for our $4. So if we have one child left, if children left is equal to 1 and the money is equal to 4, that's also a no-no. We just need to continue. We don't need to break yet. So continue. So everybody want to do all of this. So we have, there's not enough money. We have exactly 4. We're trying to give someone too much money. If the children left is 1 and we have the money left is greater than 8, so we need to do all of this again. Alright, so we have if there's not enough money for the children, if their money is exactly 4 if there's 1, and if there's more than 8 for 1. What else? Okay, let's just break. Here, this is our while loop. And then we can just return this. This might not work, but we're trying. Holy. Holy. That was crazy. Wow. It was really this really. Oh, where did it go? There was a discussion question that really broke it down. I can't find it anymore. Okay, so where the money is less than the children, we take care of that. Where the money is more than 8 times the children, where the money is equal exactly. Yep. Okay, so let us submit it. That's a lot of test cases. So I passed like half. Okay, let's look at solutions. I don't think I've done. I need to spend more time on this. Develop a formula, find the points where, again, exactly 8. Okay, this is a lot. Is this Swift? Yeah, it is. This is a win. This is a good one. First, give each other $1. Count how many children you can give 7 or more to. Obviously, this number can't be greater than children. Result children. Okay, so I did that. Okay, this one is divided by 7. Okay, this is almost similar to what I was trying to accomplish. Okay, so that was 2591. Distribute money to maximum children. We need to clean it up a bit more.